Welcome to CS420 Programming Languages, and this lecture is about object-oriented programming. So what we want to cover is whether or not every object has a root object. And then we'll cover multiple versus single inheritance, interfaces or protocols, extensions or mix-ins, variable inheritance, method dispatch, and then how we create the object environment that we run code or methods that have been called on an object. Now, when you're going to create a language that has object-oriented programming in it, one thing you need to decide is whether or not your classes automatically inherit from a root class or a root object. And in Java, they do inherit from a root object, and there's a class called object that every other class inherits from. In C++, you don't have that. The cool thing that you can do when you have a root object is add methods that you know that every object will have. For example, in Java, they have a description method, and whenever you print out an object using system.out.println, it calls the description method. So you know that you can call description on any object. Now, the classes you actually create in Java, you can overwrite that description method and have it print out something different, but then it will work with all the system.out.printlns. You can have a custom printout for your class. Now, another thing that you need to decide when creating an object-oriented programming language is whether you're going to have single or multiple inheritance. In Java, you have single inheritance, and what that means is you can only inherit or extend one class, or versus C++, you can inherit from multiple classes. And what that means is if you have one class, say an animal class, and another class that's like object that moves class, and you go to create a dog class, it can inherit from the animal class and the thing that moves class at the same time. In Java, you can only inherit from one class at a time. Now, one thing that you can have in your object-oriented programming languages are interfaces or protocols. I think if you've taken classes in Java, you're familiar with an interface. In Swift, they call them protocols. Basically, you can define a protocol as a set of functionality that you have. For example, one protocol might be movable, and that means that you have a coordinate, x and y coordinate, and you have a couple of methods that say get my position and then change my position. And as long as you implement those methods, then you can claim that you have the movable functionality. And that actually becomes a different type in the language. So all throughout the rest of your program, you can know different objects. It might be different types of objects, but you might know them as just objects that are movable. And that means that you can call those methods that are in the protocol. So that's one way that Java, that does have interfaces, gets around not having multiple inheritance. So you can only inherit from one class, but you can claim to implement several different interfaces that gives you certain functionality. And that increases the polymorphism that you have in your object-oriented programming, that classes can behave and be different types. Now, another thing you might have in an object-oriented programming language is an extension or a mix-in. And basically, you implement a certain functionalities or methods, and then a class can mix that in or extend their class with new functionalities. So extensions and mix-ins increase the ability to write code once and then have that code apply to different classes. Now, this is just meant to give a very brief overview of these concepts in a language. So if you're studying a specific object-oriented programming language, you might want to look up these things and see how they're implemented, see if you have them in your language, and then figure out how to use them, because they can really help you write code faster and only write functionality, say, once, and instead of having to repeat yourself. Object-oriented programming, one of its main goals is to help you not have to repeat yourself or write functionality that does the same thing multiple times. Now we're going to talk about static versus dynamic variable inheritance. And this deals with variables that are named the same in the parent class and the child class. So let's say the parent class has a variable x and the child class has a variable x. What x do you use when you're running code inside of the object? I'm doing this example in Java, but you can do this, create the same example in a language that you choose to see what it does with its variable inheritance. So I have a root class, object C1, and it has two fields, x and y, and I have a getter and a setter for each one of those. So I'm calling it x1, the 1 referring to because it's in class C1, and x because it's setting x. And this, of course, is setting y in class C1. And then we're going to get x and get y. Now class C2 extends class C1, and you can see that it declares a variable inside of its class as y. Notice that's the same name as this variable up here. And now we're going to have a getter and a setter for each one of these. So this just sets the variable, and then we get the variable. This gets the variable in x2, and this gets the variable y. So this x because it gets x, and 2 because it's in class C2. And of course this gets y. So our main question is, I think it's kind of uniform that this y right here refers to this y. But this class has been extended, so when we set this y, are we setting the y in the class C1, or are we setting the y in class C2? Which y are we setting? And that also gets, when we return y, are we returning this y? So when we see the variable y, are we referring to this one or the one in the child class? Because the child class extended this and declared its own y. So to test this out, we're just going to have a main method here that creates a type, an object2, it's of type C2, and we're going to go ahead and set x1 and y1 and y2, and then we're going to get all 4 of those variables out. Now I've just used my text editor here to hide the body of these methods, but I'm just trying to condense the code down so that we can see everything here. And you could see at first we call set x1 to 101. So that's obviously going to call this method, and since there's only one x, it's obvious we're going to set this one to 101. Then we're going to call set y1 to 102. So y1, was that going to set this y to 102 or this y to 102? So we'll need to find that out. Next, we're going to set y2, which is this method right here, and that y2 I think is going to set this y to 999. So if we have static variable inheritance, when we what that means is when we write this method right here, this set y1, when we write this method and we say y, we're saying the y that we know is already created because it's created in the class that we're referring to. So that's static. Versus dynamic variable inheritance, when we set this y, that means that it might not be this y because later on someone extended our class and created another y, and that switches it from using this y to this y. Anyway, when we run this code and we get all of our variables, if we have static method inheritance, when we get y2, that should be 999, but when we get y1, that should be 102, because y1 was set to 102 here, and then we get it from the class C1, so we get it from the parent class, and if it's 102, that means that we always use this y. Whereas if it's 999, that means that because somebody extended our class with a different y, that we suddenly switched and started using this 999. So here we can see in this right here, and that's this method, this get right here, we could see that we have 102 instead of 999. That means that Java used static variable inheritance. It used static variable inheritance, and we know that because when we set y1 to 102, that set this guy to 102. When you set y2 to 102, or to 999, that set this guy to 999. And then when we get y1, we still have 101. When we get y2, we have 999, which tells us that these are using separate y's. And that's how we know that this is static variable inheritance. However, if I would have gotten 999 here, then Java would have used dynamic variable inheritance. So if you're doing this for your own language, you would have to create this little sample program and run it, and then your test is going to see what this is. Next, let's talk about static versus dynamic method dispatch. What that deals with when methods have the same name in a parent and a child class, which one do we call? Now here in Java, I've created three separate classes, class C1, class C2 that extends C1, and class C3 that extends C2. Now, each one of these classes, now they have the same name. Notice method 1, method 2, method 1, method 2, method 3, method 1, method 2 in each one of those classes. So what we're going to do is we're going to create a new object of type class C3, basically this last one, that inherits from from C2, which inherits from C1. And we're going to go ahead and call method 3. Now luckily, there is only one method 3 right here. So what method 3, now all of these methods return an integer. So what method 3 is going to do is it's going to call method 1, but it says super method 1. So what does that mean? Do we call this method? Do we call this method? Or do we call this method? And as we know, the super means to call the method from the parent. So that will call this method right here. Now method 1, now we have a return this dot method 2. So which method 2 do we call? Do we call the method 2 that's in the same class as us? Do we call the method 2 in this middle class right here returning 23? Or do we call the method 2 in class C3 that returns 33? So if our test, by the way, super always means we do static method inheritance, and we always look in this super class. So we know that this method 1 is always going to call the parent's method 1. That's the definition of super. But now we want to determine if we do static or dynamic method dispatch from this method call right here. Does this method return the method 2 that in the same class? That would be static method dispatch, meaning we get 13 back. Or does this method 2 call this method or this method? Now this method doesn't make much sense. It's kind of sandwiched in the middle. So we want to know, does this return 13 or does it return 33? If it returns 13, then we do static method dispatch because we call the method in the same class as the class we're running the method in. Or if it's dynamic method dispatch, we would return 33 because we call the method that is in the class that that object really is. So let's see what Java does. And you can see we got 33 back, this one right here. So it does dynamic method dispatch. Now usually dynamic is really bad because we don't want, when we call a method, we want to know exactly what method we're calling. But if we did dynamic method dispatch, we would lose a lot of polymorphism power in our object-oriented programming language because we can never overwrite this. But by doing dynamic method dispatch, when we extend a class, we can change some of the methods of the root class and modify the functionality of that. So by having dynamic method dispatch, that allows us to create more polymorphism or make our object act different than the parent object by changing some of the methods in the parent. So that's why Java does dynamic method dispatch. Now most languages do dynamic method dispatch, and most languages have static variable inheritance. Although you're not sure, and if you probably Google that, you probably won't find much of a result on that because it's just not a question a lot of people ask. But to test it, you just do this little sample program, and if you get 33, then you know you have dynamic, and if you get 13, then you know you have static method dispatch. The last thing we'll cover in this class is how do we create the environment for an object. When we call a method on an object, we have to take all of the member variables and make them available in our environment so that they can access it. To see how class environments are created, I've created a little sample program here where we have one class called point who has an x and a y field, and we can move the point and figure out where it is, and then a class color point that extends point, and it basically just adds a color onto the point and to be able to set and get the color. Now in our main method down here, we create a new variable p, which is of type point, and another variable called cp, which is type color point. So the let would extend our environment down here with p and cp. And basically what we need to store is the variables x and y when we have a point. And when we have a color point, we still need to store our x and y, but we also have to store our color. So this would be some sort of struct or object that keeps track of all of the field variables inside of our class. And when we have a class that extends another class, it kind of becomes a linked list with all of the different data structures, one for each class that we inherit from. Now let's say that we want to call this method move on the object p. So step one would be able to look up p in our environment and see that it's an object. Now if you notice, I stored inside of this the type that it is. So this is of type point. So that means that we need to look through our classes right here. Now notice the method bodies. We didn't store that inside of this this structure right here. We'll just store this globally, and it will be kind of a lookup. Whenever we call a method on point, we'll go to our class environment that has all of our classes, and we'll look for a class named point. And once we find the class named point, then we'll look for the move method inside of that class, and we'll find this class. Now what we need to do is create an environment, and if you remember, the environment has all of the variables that are in scope. So we need to create an environment that has x and y in scope. It also has the parameters that are being passed in, dx and dy. So when we call this method, out of this information, we need to construct an environment that we can run the method in. So this is the environment that could get instructed when we call move and pass in 3 and 4. So what our system will do is first it will look up p, find out the point in the environment, find its class name, look in the class environment for a class called point, and then look through that class for a method called move. Now it knows that there is a move method in the class point. So what it will do is it will create an environment with the fields. So now we have x and y in scope with the fields that it was initialized to, 3 and 4 right here. And then it will extend the environment with the parameters to the method. So we got dx and dy. And if you notice, we are passing in, when we move, 3 and 4 for that. And I just mixed those values up. All right, there, now we got it fixed. And we're also going to add in a couple of extra things to help us because it's object-oriented programming. First, self, or this. Whenever the person types this or self, we need to know what they're talking about. So in this case right here, self points back to the original object. And then this super, if you notice I put a percent sign, because say in this language you can't ever create a variable that starts with a percent sign, but this is just a place that we can store the super class in case they make any super method calls. We know what class to look in for those method calls. So once we got that environment set up, we can go ahead and run the code of the method. And so you can see that we're going to change x and y. And what that will do is it will change x, it'll add x to that, and we'll get 6. We'll also change y by adding the y value, which is 4, and the dy value together, and we get 8. Now, to note, this little box right here is the same box that we have here. So hopefully those are maybe pointers to the same array or vector that stores those values. That way when we change them up here, it also changes them down there. And then when we're done with the method, all of this would get erased, and we're ready to run the next method call right here. And when we run that next method call, we need to rebuild a new environment for it. So now when we call this, first thing we look up CP in our environment and we find this. And we ask, what class are you? And we look class color point, and so we know it's class color point, and we know that we're calling the move method. So we look for the move method in the class color point. And guess what? We don't find it. There's no move method. So our next step is to look in the point class for the move method. And now we find the move method in the point class. So the objects class is color point, but the class that's hosting the code is point. So we'll call point the host class, and point hosts this code. So what we want to do to implement static variable inheritance is we don't want color in there, because the variables in the child class should not be in there when the host class, when we're running a method for the host class. So we end up creating an environment with only x and y here. So basically when we know that point is the host class, we only include the variables from it on down. So if there's another class it inherited from, there'd be another environment here. But we do not include the color in this environment. Next, again, we're passing in 10 and 20. So we have our dx and our dy. And now look at self is pointing to class color point. And that will help us implement dynamic method dispatch. So if I were to call a method inside of here that gets overridden in the child class, what we'd do is we'd look up self, find this environment, and we'd start looking in the color point class, the child class. But the method itself works the same. It's just going to add this and this together and this together and change the values down there. So once again, this box right here is the same box as this box in memory. They just have a pointer from this to that box, and this has a pointer to it too. So when we change it here, it also changes it there. Now I actually made a mistake. This shouldn't be point. This should be object. The reason why it should be object is because the host class that hosts our code is called point. So super would mean it's its parent class. So we should put object as the super method. And once we're done executing our code for the move method, we can let this environment get garbage collected or destroy it, give it back to the system, and then we were able to move our point. And that's how we build environments for object-oriented programming. Every time we call a method, we have to create an object environment to run the code so that its fields are in scope, and we have to store some other information to help us with the this or self pointer and to be able to make super calls.